Hello everyone. Today's day 33 or actually today's day 34 of solving a LeetCode problem every day. And today I'm going to be solving level order traversal of binary tree. So given a binary tree root, return the level order traversal of it as a nested list where each sublist contains the values of nodes at a particular level in the tree from left to right. So in this case, we have this tree right here, and what we're doing is we're outputting nested lists of each level of the tree. So for this tree, we're going to have a list of just one, then a list of 2 and 3, then a list of 4, 5, 6, and 7. So we have 4, 5, 6, and 7, 2 and 3, 1. And the reason why is because these nodes are all on the same level, these nodes are all on the same level, and this node is in the same level. And this is the order in which they appear in the tree. So basically what we need to do in this problem is traverse this tree in level order. And if you don't know what a level order traversal is, it means that we're going to traverse the tree from left to right, level by level. So in this tree, it's going to be in the order of 1, 2, 3, 4, 5, 6, 7. And as you can see, that's also the same order of numbers in the output right here. So the way we're going to implement a level order traversal is by using a queue. So pretty much what we're going to do is we're going to first add the root to the queue, and then we're going to traverse through the queue, add each element in the queue to a list, and that list is going to be the current output for the current level. But what we're going to also do each iteration is add its children nodes to the queue so we can continue traversing. So it's going to make more sense in a second. Let's just start coding it real quick. So first of all, we're going to start by defining an output queue, an output list. And this list is just for the output. So it's going to be this right here. And then we're going to next initialize a queue. And we're actually going to use the double-ended queue class to do this. The reason why is I'm not sure if there's a built-in just queue class in Python, but the other option would be to use, or the other option from the top of my head would be to use a list. But the problem with just using a regular list is if we want to pop an item off the queue, so off the very left side, since this is going to be a first in, first out type of situation, it's going to take O(n) time, while a double-ended queue is optimized to pop an element off in constant time. So that's the reason why we're using a queue, or a double-ended queue. So that's why we're using this specific class right here. But next, we're gonna start out by appending the root to the queue. And then what we're going to then check is if the first item of the queue is just none. So that would basically mean that the root that we were passed is null. So if that's the case, we just return an empty array. Otherwise, we're going to start by iterating through our queue, and then we're going to define our current array. And what this is basically going to do is store the current list for the current level that we're traversing. And then we want to say for I in the range of the length of our current queue, we are going to pop the element that is next, and then we're going to check if this element has children, and if it does, we just want to append these to the queue. And then finally, we just want to the current array, so this current array right here, we just want to append the current node's value. And one thing I also do want to mention here is, even though we're manipulating the length of the queue right here, it's not going to affect whatever value is passed in over here. And the reason why is because we're not passing a reference to the length of the queue. We're just passing in the value the value itself. So none of this is going to affect the loop. But anyways, then after this loop is done executing, let me fix this real quick. I'm not sure why it's all the way up there. But yeah, once this is done iterating, what we're then gonna do is just say output dot append current array. And what this does is to our output, we append whatever that current list is. And then at the very end, we just return the output. So let's try running this. Cool, so we passed these test cases. So as for time complexity, let's see. So it's going to be O of n, and the reason why it's O of n is because O of n is because we're just processing each element in this tree once, because we're traversing the tree in level order. Then our space complexity is also going to be linear. So let's see. Just a little bit more of an explanation of how this solution works. What we're essentially doing is we're building out a queue. So let's say this is our queue right here. And then what we do is we pop the root, or we append the root to the queue. So we append 1. And then what we're doing is we're looping through this queue, popping that element off. So we'd pop the 1 off, but then we'd add its children, so 2 and 3. And then once we do that, we do the same thing for these elements. So we'd, for example, pop 2 off, and then we'd add 4 and 5 in. And then we process this 3 and add the 6 and 7 in. And then we're done with that level, and we're ready to process the next level. So I'm not sure if that made any more sense, but that's pretty much how the algorithm works. So yeah, that's my solution for the day.